So we are on the last topic of combinations and probabilities. So if you're watching this video, I just want to say good job, well done. You've done excellently well catching up on all of the other topics. And this is the final one. And this is talking about binomial probability. So it's essentially asking if you have a number of trials and you're trying to find the probability of k successes, we can represent it as this formula right here. Px equals k, where k is the number of successes, equals to n choose k, p to the k, times 1 minus p to the n minus k. Whew. And on the right here, I've listed out the 4 assumptions that make binomial probabilities. The first one is that each trial has only 2 outcomes. It is either a success or a fail. That's it. There's nothing in between. Number 2 says that the probability of success is constant on each trial. So the probability of success does not change on each trial. Number 3 says that the number of trials, n, is fixed in advance. So again, this is not dynamic. We do not change the number of trials as we do the trials. And number 4 says that trials are independent of each other. So one trial does not affect the probability of another trial. So the most basic type of example here that I brought is this. It's when a bias coin that has a 40% chance of getting heads is tossed 4 times, find the probability that it lands on heads 3 times. So, as you might see here, the number of trials we set is 4, so you're tossing this coin 4 times, and that we're trying to assess the probability that it lands on heads 3 times. So, we can kind of expect it like this. And the probability of getting heads is 40%, so this is going to be 0.4, and this is going to be 3 times 1 minus p is 0.6 times 1. So that is the probability of getting 3 heads in this bias coin out of 4 trials. And make sure you use the calculator. You do not want to multiply this in your mind or by hand. Always use calculator for binomial probabilities and really any probabilities. Most of the questions you'll be doing is going to be in paper 2, not paper 1. So it's important that you use the calculator. And this is going to be equal to 0.1536. And I've listed out this x binomial NP. This is calculator notation, so you're also going to be able to directly input this scenario into a calculator. And you'll have to specify n, p, and k. So that's it. That's binomial probabilities. And hope you have a great time practicing this.